Hi everyone, in this video we are going to learn about a special kind of vector field called gradient field. For that we have to recall something that you've learned from Calc 3, which is the gradient of a scalar function. So if you have f is a scalar function, meaning it's just your regular function whose output is a scalar and not a vector, of two variable, then we can define a vector function and define a vector function as gradient f xy is the partial with respect to x and assign it along the I cap, which is the x direction, and the partial with respect to y and assign it along the y or the j cap direction. So this gradient is a vector field because it satisfies the conditions for a vector field and gives us, for every point xy, gives us some vector. And it has a special name. It's called the gradient vector field, and it's going to play an important role in a lot of the things that comes up in this course discussions, and specifically we're moving now more into part which is useful in physics. In 3 dimensions, similarly, if you have a scalar function of 3 variable, then as you would expect, you would take the x, y, and z direction partials and assign the appropriate directions I, j, and k to them. Simple problem here. Find the gradient field of this given function. So all we have to do is find the partial with respect to x is 2xy, partial with respect to y is x squared minus y squared. So the gradient field del f xy, you can either write this as 2xy I cap plus x squared minus y squared j cap, or you can use the more concise notation for vectors, which is using the square bracket, triangular bracket, I guess. Note, this is something we will come back to later, so it's not that you have to understand it right now. If a vector field can be written as the gradient of some function f, then that vector field is called a conservative vector field. Okay, so this notion of conservative vector field is important and recurrent. So we will be looking at it in some form or the other. And what happens is, whenever there is a conservative vector field, there is a law of conservation that is also obeyed by nature. So which is what makes it interesting. That brings us to end of vector field discussion. In the following videos, we will be looking at, since we've already done derivatives of vector functions, now we're going to look at integrals of vector functions. And the first integral that we're going to look at is called the line integral. That's it for this video. Thanks everyone.